right, hello everybody. Thanks for joining us today for our bi-weekly Free Friday webinars. The webinar today is going to be on importing and exporting coordinate data in RoadEng. And I'm Kamala, and Craig will be the one here doing the more technical part of the demo. But I'm going to start with a bit of an introduction. And as always, we're going to be recording today's webinar, so you can pass it on to anyone who missed today, or if you'd like to watch it again. And Craig has control. There we go. So just a quick outline. It's going to be a very straightforward webinar today. Just 2 points or 2 main themes that Craig's going to talk about. He's going to talk about coordinate systems using working with Google Earth a bit, and then he's going to talk about exporting. And of course, today's webinar is going to be done in RoadEng. We'll be using the 2 modules of RoadEng, which are the terrain and location module. And before I pass on to Craig, this is a list of our next 3 upcoming webinars, so please take a look and sign up for a couple or for all of them. And with that, I will pass things on to Craig, and he's got a couple slides at the end here to just get started about telling you about coordinate systems.
Thanks, Cam. Good morning, everyone, or good afternoon, wherever you might be. Before I get going, I just wanted to let you know that you can ask questions through you should have a panel that you can ask them through. Please go ahead and do that at any time, and I'll try my best to keep up with the questions as I go. The plan was to fill a full 30 minutes with this seminar, but I have a feeling it will probably be a bit shorter. We'll kind of have to see how it goes. Yeah, so jump right in with questions, and we'll just try and answer them as we go. So I'm sure everyone here is familiar with coordinate systems. If you're in the business of designing roads or sites, these will be familiar to you, but I thought I would just bring them up here as an introduction. Here are some of the common coordinate systems that we see, the top 3 in particular, and there's all sorts of coordinate systems that are available, and I'll explain how those work with RoadEng a little bit more, but there are many of them. The final one, geographic coordinate systems, you can actually work to a certain extent in terrain with lat-long coordinates, but it's not recommended. Things like calculating areas and distances don't work with lat-long coordinates, so we tend to discourage that coordinate system. So what are the benefits of working with coordinate systems? Again, this is probably pretty obvious for you in the business, but I think the biggest thing about coordinate systems, known coordinate systems, is you can mix different types of data. You can bring in a field survey, you can get some LiDAR, you can bring in some GIS maps and combine all those things together without much effort. They all work, and you can convert between coordinate systems. So there's a huge advantage to being organized and working in a coordinate system. The other thing, obviously, is that once you have the coordinates, you can go out and lay things out using GPS, and again, you don't have to worry about control for where your points are lying. And the final thing is that you can take this data out of RoadEng and bring it into a GIS system for archiving purposes, and you know where it is geographically. So it's very useful. In the time that I've been working with Softree, I've seen a big change in the way people work with coordinate systems. It used to be unusual to see georeference coordinates, and now it's almost everyone uses them. It's ubiquitous. Anyway, let me just jump right in here, and I'm going to start by showing you a terrain program. One little one here that I've put together. So this is a boundary survey with a few roads in it, and I happen to know that these coordinates are in a particular coordinate system. So terrain lets you set the coordinate system up, and you can choose from a variety of different ones. You can see lat long, UTM, US state plane, and many others. You can create custom coordinate systems within terrain. I happen to know this one. It's a UTM and it's zone 9. Yeah, so how do I know this is the right coordinate system? I think this is one of the things that comes up quite often. Someone gets some data from someone, they're not sure what system it's in. There's a very useful technique for determining that, and that is to simply set the coordinate system in terrain and then export to Google Earth. So I can save this file. I will choose Google Earth format, KMZ, where are you? There we are. And save this file out into Google Earth, and I'll open up Google Earth and just have a look at what happens. I love Google Earth. I spend a lot of time poking around with it. I do outdoor stuff, so it's a fantastic program. But for this purpose, for determining if you're in the right coordinate system, it's very useful. So I can see here, by just taking my data, saving it out into Google Earth, that it is in the right spot. If I get the coordinate system wrong, just delete this, try this again. Let's suppose that I thought I get it wrong, and I say, okay, this is in zone 10. This data is in zone 10. I do the same process, and it's not going to fall in the right place. And I'll know immediately that I've got the coordinate system wrong. So it's put my boundary and roads and so on in completely the wrong place. I know I'm in the wrong place. So Google Earth is really handy for that, and a lot of other things. It's very good for presentation and that sort of thing. Okay, so one might ask how this map got georeferenced in the first place. This map was created from traverses, and the traverses were entered using our survey module. And I'll just bring up a traverse here. It may not actually match this one, but I'll show you the concept. There's a traverse. How did this traverse get georeferenced? Simply by setting the start station to a known coordinate. So here I would enter a UTM coordinate in zone 9. I would set that coordinate, and it would just shift the coordinate into that coordinate system. And I might have some other tie points along the traverse which I wanted to set also, and I could set those as absolute coordinates. So this would shift and position my traverse at the right place geographically. Okay, so let's have a look at another example. This is a resource situation, a resource cut block and roads. I have another county road project, similar sort of idea. I've got some survey data in here, and I have a coordinate system set up. In this case, it's actually a county in Minnesota, and they've put in a very specific coordinate system, which is custom. It's not something you'd find. It's not very common. And they've created what's called a WKT string, which represents all the parameters of the coordinate system. That information is generally available. I won't get into all the parameters and spheroids and all this sort of stuff, but this information is available to build specific coordinate systems. You can also get a coordinate system from what's known as an EPSG number. It's a general, easy way to get all this information. It's just by simply entering a single number. So we've got a custom coordinate system. In this case, it's in U.S. survey feet. And just as I did with the block survey, I can just save this one out to Google Earth and make sure that it lands in the same place, in the right place. Just as a check, KMZ, again, Google Earth. Saves everything out. There's more information this time, and it's going to take us somewhere else in North America and plop us down to a county road project in Minnesota, but we know we've got the right coordinate system by simply doing this. For some reason my Google Earth is not letting me zoom in here. Anyway, you get the idea. So the next thing I wanted to show you, I'll go back to my simpler example, setting map, and suppose I have I've got this map created and I want to insert a GPS traverse into here that I've done after this map was created. So I'll go File, Insert. I've got a GPS traverse that was done later. Just going to insert that in. When I go to insert it, it notices that the GPS file is in lat-long coordinates. Many types of files have the coordinate system with them. For instance, shape files know which coordinate system they're in. GPS files do. LandXML do. Some don't. It all depends on the file type. If the information is not with the file, then you have to explicitly enter it yourself. In this case, GPS file, it's in lat long, and we're going to convert it to zone 10, which is wrong. I know. Let me just change that. Module setup. Zone 9. And I'll try that again. File, insert file, traverse extension, lat long to now zone 9. And it's going to do a conversion. It says apply a transformation to go from lat long into zone 9. Does that, and you can see down here I've got a traverse that was actually located using a GPS mixed in with a conventional survey, and it's all in the right position. It's kind of cool. And then again, I can check it by simply saving this out to Google Earth. Always good to do that. I won't bother just yet. Okay, so you notice that I can change the coordinate system, and when I do that, it actually doesn't change the coordinates, the underlying coordinates that are in these features. And you can see the coordinates down here. You can also see the coordinates. Let's resize my window here. You can also see the coordinates in what's called the points window. New window, text, points. Just going to go in here and add coordinate information in here so I can ignore the elevation. I could also include lat-long coordinates. Take this out. So there is in the points window, I can see all my coordinate information. And the way this works is you select some features, and then you press display selected features here, and it adds all those feature points into the points window, and the columns are, the first column here is the name of the feature. And you can actually move around, navigate around in this window. But the point I wanted to make here is that if I change the coordinate system, I'm not really changing the coordinates if I change it in module setup. I'm just telling it that it's in a different coordinate system. So what if we converted these points into another coordinate system? Suppose our client wants them in BCL bears. It's pretty common here in BC. We can do that. And the way we do it is we select all the features. We go up to the menu, Modify Selected Features, Coordinate Transformation. And the current system, the from projection, is in UTM Zone 9. And over here, I want to go into BCL bears, which I happen to know. I happen to know the EPSG number for that, which is 3005. You can see it's figured out all the parameters based on that EPSG number to give me a BCL bears projection. So from projection, UTM Zone 9, to projection BCL bears, still in meters. I go ahead and do that. Apply transformation. And now if you're quick, you notice that the coordinates actually changed. We're now in a different set of coordinates. And here's my data, and it's been converted. It's been converted into another coordinate system, which you may want. The lat long should have stayed the same. They should have stayed the same. Okay, so one thing I probably want to do right away is check and make sure I did everything correctly. And again, I can use Save to Google Earth to do that. Now my SETI map, Google Earth, and I have kind of a confirmation that I am actually in the right place spatially with this data. It's a great way to check things. Yep, we're back here, same spot. We've got that extension traverse thing. So Google Earth is very, very useful for checking coordinate systems. If you get some data from someone, you may even guess at what coordinate system it's in. Pop it in and check it using Google Earth. Very useful. Okay. Is there any questions? Let me see if there's any questions. No? Pretty quiet. Yeah, the next thing I wanted to show you, before I leave here, coordinates. Another way to get at the coordinates for these features is through the edit menu. So I can select a feature, so click on, that feature, edit, modify selected feature, coordinates, and here are all the coordinates. These are now in BCL bears. I can go through here, I can see where they are, I could change them, and all that sort of thing. I can display these coordinates in lat long format. I can also display them in survey format, which is essentially bearings and distances. So the coordinates are all in here. And the other thing I can do, of course, is to copy this clipboard information. Copy this data window information to the clipboard and go over here to Excel. Somewhere here's my Excel. I normally have it as an icon on my desktop, but someone took that away from me. Microsoft Office, Excel, there we go, and paste it into Excel. So I can move coordinate information out that way. And of course I could save the coordinates out, save as in other formats. The simplest is in an ASCII format, shapefile, ASCII format, and so on. Okay, let me move around a little bit here and switch over to location and show you a few things about saving out a location into a form that you can use for stakeout. Okay, so here is a completely different design situation. This is a rural highway, quite a long road, and I want to know how I can get information out of RoadEng so I can slope stake it, give it to a surveyor. The most straightforward way is to put it into what's called the data window. So I create a data window, and I'll set the columns up in the data window to include columns, and I'll take these out, and I will add centerline coordinates, centerline X, Y, elevation, gives me my center line. I might also want to add some point codes on the cross section, and I can find out the point codes by simply zooming into the position on the cross section, hovering at that position, and I should see there, you can see RER, that's my shoulder point on the cross section. Similarly, if I go down the ditch here, there's a DIR, and so on. So let's suppose I want to export the shoulder points as well as the center line. So I just go into my data options, template codes. I'm going to add REL, and RER. And you see the other ones there, DOL, DI. Once you get used to them, you don't need to do this hovering. You can just set them up, recalculate everything. And, oh, I need to add them in as columns. I added the point codes. I have to also add them in as columns, and they appear here under template codes. And I can add several different types of information. I can add offsets from centerline, horizontal and vertical offsets from centerline, or coordinates. So I can just grab those, include those in my output sheet. These aren't probably elevation. That might be original ground elevation. So that's the original ground elevation at that point code. Other information here that you could, that's associated with the point ground. Okay, so it's now in my data window, and I can print it, or I can do it again. What I did a minute ago is to copy it to a spreadsheet. Copy to clipboard, data window over here, and paste it into a spreadsheet. So that's, I've got to do something with the delimiter. How about save as txt? The problem I'm working around is I have the wrong delimiter here. Copy to clipboard, data window. Yeah, for some reason I've got a comma delimiter, and so copy, I would have to save it out as an ASCII file. There's some way to change that delimiter. I'm not exactly sure right now. Anyway, you get the idea. I can save the coordinates out in a form that's readable into a spreadsheet. And you can upload it into your data collector, print it out, that sort of thing. The other more common way to get survey staking notes out of the location is a format called LandXML. And to do that, I just simply go File, Save As. I choose a LandXML format, and a dialog box appears. First of all, the center line alignment, both horizontal and vertical, is saved in the file. You don't have any choice about that. But you do have a choice whether or not you want to include cross sections, and that's what this dialog box is all about. So I'm going to have include sections, and I'm going to tell it that I want my section spaced at 20 meters. And this other information here, you can sift through it, but essentially I can select a surface, which surface I want from my cross section. In this case, I'll take the subgrade surface. And some of this other information is for things like road widening, where the cross section is actually divided into two halves, a left and a right. And some data collectors want it all to be in a single polygon. They want to have the center line included. Have a look at the documentation for further explanation on some of these options. So I'm just going to go ahead and do this. Takes a second, and when it's finished, I should have a file. There it is. And it's an XML file. If you're really perverted, you can actually open this file up and have a look at it. It's sort of readable. It's in a kind of a computer jargon type format, but it is readable, and it will upload into most data collectors' land XML format. The final thing I wanted to show you is how to check that file. You've exported it. How do you know if it's right before you give it to a surveyor? And there's a trick to doing that. Just minimize this window and start a new location design. And I will actually create another RoadEng project from that file. I have to give it an original ground surface, so I'll choose the same surface as the other. And then when it asks me for the initial alignment, I'll tell it that I'm working with a land XML file. Here's the XML file that I just saved. I'm going to bring it in, and I will enable the vertical alignment, and I'll tell it to use sections that were in the file. I read it in, and somewhere here I have a window called fixed. I have to get resizing here. I have a window called sections. And if I enable that, and I look over here, you can see I can jump to a particular section. We can have a look at it in the window. And let's just look at some of these sections. And you notice that that was the section that was exported. And it's sticking through the ground at that location. The reason for that is we don't have stripping. This section represents the cross section after it was stripped, and in fact I can enable stripping here. Apply stripping just to see that effect. Stripping. I'm going to cooperate. Apply stripping. Seems like it's not going to cooperate with me. Yeah, in any case, this layer is matching the stripped layer. And I could also, in the original design, have exported other layers such as stripped layer or finished grade equally as well. One very last comment here is that from location I can actually save information out as a surface. That was cross sections that I saved before. I can also save from location. I can save into a terrain surface. We've got actually a new file, so I'll save as a terrain surface, call it rural highway. And I can choose point types, and I'll choose the surface that I want. Here's my selection, strip surface, subgrade, and so on. Let's go with subgrade again. I'm not going to include the center line, and I might want to include a boundary on the surface so that when it creates a model, it's got a boundary. And yeah, there's a typical set of options. Let's go ahead and do this. Exports the surface and then brings it up in terrain. And we can see there is the subgrade surface, and over here is you can see a 3D rendering of that surface. So some total stations and some data collectors prefer to work with surfaces, so you have a choice. You can go with cross sections or surfaces. And that concludes what I wanted to cover today, today's seminar. Are there any questions? Don't see any questions.
There's one question there, Craig.
Oh, there is one question. Maybe you can help me find it, Cam. I'm a bit challenged with this whole system here. How do I see that? When I export to Google Earth, my line colors aren't retained in Google Earth. Is that true? Could be. Do I still have some of these line colors in Google Earth? They look pretty similar to me in the ones that I had. Sorry, too many files going on here. I don't know. Maybe that's a subject for our support group to look at if you're not. But in the one I did here, it looked pretty good. The line types are not preserved, and I assume that's because Google Earth has a different set of line types, or maybe a limited set of line types, but the colors seem to match fairly well. Okay. How do we look up an EPSG number? Yeah, specifically we use a county coordinate system. That question, I think I would Google to find out your EPSG number. There's all sorts of sources on the internet that could give you that. If you don't have a GIS person, I don't know if there's any one specific spot, but I think that question would be best answered by Mr. Google. Another question, can you import coordinates from Excel? And the short answer is yes. There's two ways to do it. One is to save from Excel a coordinate file. Let me just illustrate that. So you've got, now you have to find Excel again. Let's go over here. Yeah, so I actually created these coordinates by exporting, but I could have equally well have imported these coordinates. And what you do is you save from Excel in a CSV format is the best. So I could save it in a CSV format, all kinds of options here. And then you can read it in from a CSV format directly into terrain. This is how you would get total station data in. Pretty common. So there's a CSV file. Save it. And then come over here and we can read it back in. So there's the CSV file that I just saved. Close that. Start up terrain. I'll start another instance of terrain, be easiest. Terrain. And I can go File Open. And I choose all supported files. I have CSV in my list. If I go to open that, says it's a text file. There's actually lots of tutorials on this specific topic. It's reading in the file, it looks at it, and it lets you choose where the coordinates are in the file. So with this file, I want to skip the first line because it's a heading. And then I'm going to look at the next record. Okay, now it's telling me that X is in 0, Y. See, this is obviously wrong, so I probably want to change this to 3, 2, 4 maybe. That's still not right. What have I got here? 2. And I'm not quite. This file looks a bit whacked out. You get the idea. You can read this file in much the same way you can in Excel. You choose where the X, Y, Z positions are. You read it in, and you'll have a terrain file with those points in it. You can also connect up the line work. So if it's got codes on the points, you can connect the codes and form polylines. If you're interested in more about this, it's actually the subject of another web seminar. I can provide you with more information about the whole process.
Just before we answer just the next question, there's just, I think, one more question. But if anyone has to duck out, this webinar is recorded. I think that was one of the questions. Is the webinar available for later viewing? Yes, it is. So you'll all be emailed the link to the recording if you don't have time to stick around for the last question.
Okay. There's actually two more questions. Oh, okay. How close should RoadEng file work in Google Earth, for example? If the road design, I'm going to need some help here. I can't see it.
The road design.
I think I get the drift of it. How close should it be to Google Earth? It really depends on what your requirement is. I mean, you actually don't have to. You can work in undefined coordinates in RoadEng. You can work in a local coordinate system. They don't have to be georeferenced. The whole idea of georeferencing is so that when you come out of RoadEng into a GIS system or into some public document or something that you'd give to a surveyor, those coordinates make sense and they don't have to be tied to control points. So it's really up to you how close you want it to match Google Earth. Google Earth itself is not perfect. Certainly in elevation it's not very good. In some urban areas it's really good. In some rural areas it's really bad. So it's not an easy question to answer. It depends on what you want, what your GIS system requirements are. If you've established it with GPS coordinates, and those are pretty reliable, then you're good. That's all there is to it. Okay. I think that was it. I thought there was 2 questions, but it looks like that's it. That's it.
Well, thanks for joining us, everyone. Have a great weekend, and like I said, we will be sending you a link to the recording if you'd like to watch it again or pass it on to anyone else who missed the webinar today.
Thanks, everyone.